Hi everybody, Chris AMS, hope you're all well. Welcome to another video. Please don't forget to click that like and subscribe button and follow us along, that really helps us. Today we've got an Audi A6 2-litre diesel in the workshop. Customers come to us, they've been to two other garages and they think it might be an oil pump problem. It's got oil warnings coming up on the dashboard and the engine management light on. So we're going to get into it and have a look and see if we can confirm 100% what's going on and what this vehicle actually needs. So follow along and let's get to the bottom of this one. So we've plugged in the snap-on Zeus, first tool, and we've got two fault codes in the engine management system. One is engine oil pressure control circuit open, which is obviously going to be related to what the customer's talking about. And then secondly, we've got particle trap 1 efficiency below threshold. Now, speaking to the customer does very short miles in it. So there could be issues with it being clogged or broken. It's difficult for us to tell at this point, but our main concern today, and looking at this job, is obviously the engine oil control circuit. So we're going to look at this, and then once we've rectified what this problem is, then we'll move on to the particle trap issues. So jumping straight into our technical data system, we're using E3 Technical today. There's two things that we're going to have a look at. One is obviously the oil pressure control, which is down here. And we can see from this that the oil pressure control is a solenoid valve that is powered by the battery. After it runs through a main relay. So you've got two fuses there, the main relay, and then with the ignition on, we should see pin 1 of that solenoid valve, 12 volts, okay? And it also supplies the cylinder head cooling pump, intercooler cooling pump, and just a cooling pump. So one thing first strikes me there is if we had a power supply issue, the likelihood is we would have fault codes for these other components as well. Not to say that we won't check. Pin 2 is ground switch. So it's the engine computer will switch that component on and off via pulse width modulated signal from the ECU. So we need to get to this so that we can have a look on here, we can click on there and it will show us the location of the component as well. So that's where the oil control solenoid is supposed to be. There's the alternator. So it's on the back of the engine, or in this case it's longitudinal, so it's on the side of the engine. I've been informed there's a dirty grey air conditioning pump that sits right there that's blocking access to this, so hopefully we can get into it. The other thing I wanted to check, we're going back to CAN bus overview, is how it measures oil pressure. Now, a lot of modern vehicles, they run a oil pressure sensor, so a 3-wire sensor, and that gives you measurements in bar or millibar pressure. But this actually runs 2 oil pressure switches. So you've got oil pressure, one oil pressure switch there and an oil pressure switch here. Now, basically how this is going to work is you're going to have a low pressure oil pressure switch and a high pressure oil pressure switch. So our management system or technical data will tell us that oil pressure should be within a certain realm at a certain rev range. So assuming this is the low pressure one, if this gets to like 1 bar of pressure, it will close that switch, complete the circuit, switch the light out and say that oil pressure at that pressure is okay. The secondary sensor will only kick in once the pressure's, reached a high, 3 or 4 bar or something like that kind of thing. Or, when you're running it, whatever the bar expecting it to see at 3,000 RPM or 3,000 RPM, and then it'll go, that one's okay as well. So these, unfortunately, we can't look on live data for oil pressure for these, but if we can get an oil gauge on them, then, and if we need to go down that route, then we can potentially look at these for, we can plumb into these with an oil pressure gauge and actually verify what oil pressure is doing. So my colleague Phil, he's been out in the he's cleared the fault codes down and he's been out. Obviously, first thing we want to do is verify the problem. He's been out in it, he's cleared the fault codes down, he's driven it, he's getting no oil pressure warnings come up on the dashboard, so no little red oil can or other warnings. When he come back into the workshop, he rechecked for codes and he had that oil pressure solenoid valve circuit open. So we have an electrical problem, okay? We need to deal with the electrical problem before we worry about anything else. So let's have a look and see if we can actually see this oil pressure solenoid valve. So we're under the vehicle and access is going to be a problem. So it sits, there's the air conditioning pump and the alternator is just above it and it sits in between the two and I can't even see the thing. So we'll have a go from the top, but it might be mirrors and cameras and all sorts of stuff, but actually getting physically onto the component to test it is going to be somewhat awkward without taking some of the stuff off the vehicle, like moving the aircon pump and stuff. Let's hope we don't have to do that, but let's see how we go on. So top of the engine bay, zoom in a bit. So there you can see our alternator. Now I don't know how, I'm hoping you'll be able to see this on camera all right, but our oil pressure solenoid valve is see that? Let me take you off the mount, maybe I'll get in there a bit tighter. That doofenberry there, okay, with a little plug on it. Now you couldn't have put it in a more awkward place, but hey ho. Well, we're going to see if we can get to that and we can carry out some tests on it. The wiring harness of that runs up the back of the alternator and actually comes out here. So we could theoretically do some of our testing from here, but let's see what we can accomplish. So what we've done, because of access issues, I've actually gone into the wiring harness a little higher up. Not my favourite way of doing things. I would rather back probe the component directly, but I can physically get my hand on it very easily, and this is going to be a lot easier and time effective to do it this way. What we'll do is, obviously we've probed these wires, but we'll seal them up afterwards so they don't get corrosion and stuff in them. So first thing we was wanting to do is just to make sure that the red one's connected to the power supply to the solenoid valve, the black one's connected to the ground side of the solenoid valve. So let's check to make sure we've got a good power supply first. So we're using our power probe lead coming off the battery. We're going to use our incandescent test light to start with, so that's going into the negative of the power probe lead, and there you go, we can check to see that we have got good signal running through our test light. Now, so we're going to check this, so that's in there, and as you can see, that's lit up. So that's a load test, and that's proved that the power supply coming in from the main relay and the fuses are all okay to this. Now, to check the other side, we're going to have to break out the scope. So let's attach the scope leads and stuff up and see if we can see what kind of signal we've got to and from this solenoid valve. So I've got our scope plugged into the two wires. Let's have a look, and I've got the ignition on currently. Let's have a look and see actually what we've got here. Ignition on, engine off. If you'd like to follow me. So what we've got currently we have on the yellow trace, which is a power in, 12 volts, and on the ground control wire, 0 volts. So one or two things are occurring here. Either the engine's not running, so it's not trying to activate the solenoid valve, or there's an open circuit somewhere and it's not liking it. So let's start the engine up and see what we've got with the engine running. So with the engine running, we've got battery voltage still, but we've still got no pulse width modulated signal there. So that's something that we need to investigate. So that could be an open circuit wire or an open circuit within the control valve itself. We need to be able to do some tests through the control valve. So unfortunately now we're really going to need to get that plug off and be able to test inside it. Let me just do one other check. Oh, let's go back into there if you want that. One other test I wanted to check was to make sure, and what sometimes you get is, if we clear the codes, sometimes you get, once the fault code appears in the management system, it switches that component off. Let's go back to scope multimeter. But no, still dead, okay? So you're not going to see this pulse unless that voltage can get through the component and then out the other side, okay? So yeah, I think we've got an open circuit somewhere and we're going to have to track it down. So with a little bit of kicking and spitting, we've managed to get our wiring harness out from down to where the solenoid is. There was 3 wires running through that harness. The third wire goes to the LIN bus signal to the back of the alternator. So I've disconnected that for the purpose of testing. So we're going to get our AES Wave breakout kit of loveliness, and we are going to plug into the back of these, and we're going to run the test again with the scope, but running it through a test light and see if we can see those signals coming back and forwards. Now if we're getting good signals, that to me is proving that the wiring to and from the engine computer is okay, and then we're kind of likely to have a solenoid valve problem, at which point we'll just prove the solenoid valve is actually faulty, and yeah, recommend to the customer what we need. But yeah, let's not get ahead of ourselves. So we're going to do some tests on this wiring plug here. Now we've got access to it. So apologies if the engine's running. What we've done is we've wired our oil pressure solenoid valve out for our breakout leads through our test light. You can see with the test light, it's lighting the test light. So it means it's making a circuit down from the power supply and it's grounding it out the other side. And we've got our scope hooked in there. And this is the one that what is a little bit odd for me to see at the minute, is that we've got 0 volts and 12 volts. So it's grounding that thing that component all the time. It's not, there's no pulse width modulated signal unless, no, doesn't matter what speed we've got it run on, it's permanently holding that to 12 volts. So I think our next step is we definitely need to get into the top of that solenoid valve and make sure the circuits are right through there. Yeah, next test. So, after a lot of fishing about, we managed to get onto the back of the solenoid valve, and I've run 2 of our breakout leads to the back of there, and I've run them through a ohm meter. So we're looking at the resistance through the component itself. Now, luckily enough for us, E3 gives us that information. It tells us that we should have between 20 and 27 ohms through that component. Let's zoom in there a bit, see better. So components disconnected, we should have between 20 and 27 ohms. Now what we've actually got is nearly 9,000 ohms, 10,000 ohms. So that component isn't letting, there's so much resistance running through that component that it's actually registering it as a circuit failure. So our recommendation to the customer is that we're going to need to replace that solenoid valve. And once we've replaced that solenoid valve, then we can just double check the rest of it and make sure it's okay. But that will definitely rectify that issue. After we've done that, then we can potentially move on to the DPF issues that she's got. So yeah, happy days. So as you know, we're all about making sure we're getting the right diagnosis. And I always think, so I've got to this point where I think, yes, I've got a faulty control valve, and I'll always go, well, what happens if I fit the control valve and it doesn't fix it? What extra test would I do from there on after that? If I proved replaced the valve and it was all right, what would be my next test? And then carry out that test just to make sure everything's all right. Now, as some of you probably saw on the scope trace, we're getting no pulse width modulated signal. We could see that the control wire is being grounded, and so it comes from the ECU. So the only other potential that we have there is perhaps a shorted ground control wire between the engine ECU and the solenoid valve. So I've taken a liberty, because I like to take liberties. I pulled the engine computer out, and I've run that. So that's into the control wire. That's coming up here. Let's set you up on there so you can see what's going on down here. Now, using E3, we can tell exactly which pin output it is on the ECU. It says B3. There's a grey and white wire. So if I back probe into there, so currently I've got this set up to look for resistance, ohms testing, okay? We've got very little ohms, but I'm not worried about load or anything like that currently. All I'm worried about, because I know the load's okay because I've tested it at the other end, all I'm worried about is have I got the right wire, okay? So I've got the right wire, that's all tickety-boo. Now, from here, what I can do then is if I take the other end of my probe and I'm going to put that to ground down here, what I'm looking for is, if I've got a short to ground, I'm going to see something on my meter. I'm going to see some form of continuity between here and the ground side of the engine, and I've got nothing. So that makes me happy that between the component and the engine computer up here, that I've got nothing short into ground that could be holding that valve active, okay? So I'm still happy that we're going to need a solenoid valve, so let's get one on it. Right, so we're back on the Audi. We ordered the part in that was required, which is this component here. There's basically a little gate inside there that allows the adjustment of the fuel pressure inside the engine. So this is what we was testing. This is bolted into the block, and here's the old one and here's the new one. So we're going to put the new one in now and then test it and then make sure it's all tickety-boo. So we're installed. Let's clear some fault codes and make sure that the light stays out after a cheeky test drive. So remember, we've got our engine oil pressure control circuit open, obviously down to the high resistance running through the component, and this particle trap efficiency below threshold will be something that we'll have to look at in a bit, but let's see if we can make sure we can get rid of that light and keep that out. So let's clear the codes. So that stayed out. So test drive time, prove the fix, and then see if we need to have a look at this particle efficiency trap fault as well. So we are back from our test drive and no codes are present. We've rectified the oil warning fault that was coming on. There's no engine light on or faults recorded. Now remember from the beginning of the video that this has been to two separate garages. One replaced one of the oil pressure switches, didn't fix it, got charged for it. The second garage charged for a diagnostic, told them they required a new oil pump and didn't want to carry out the repair. And we've had a look at it, we've proven methodology, proved it was an electronic problem and not a mechanical issue. Tested the component, found the component to be faulty, replaced the component and tested the repair, and we're all good and tickety-boo. So remember, test, don't guess. I really hope you've enjoyed watching this video. Thank you very much for watching and continue to watch. Please check out some of our other videos. Click like and subscribe, and check out some of our other social media. I really appreciate it, and we'll see you in the next video. Take care.